Good morning, dear students.
Good morning, sir.
Good morning.
Good morning, sir.
Yes. So, very nice. We will proceed in finding out oxidation numbers of some elements in a given compound. So, we have taken rules. Now, we'll work out some examples. Briefly, I'll go through these rules, okay? Uh, so that you will come to know about the rules and you can thoroughly revise that one, okay? So oxidation number is simply nothing but the charge which an atom of an element has on its ion or appears to have when present along with other elements in the combined state, right? For example, when you take covalent compounds like methane, benzene and all, it is one element with another in combined state. So there it appears to have, because we are going to assign more electronegative element negative, less electronegative element positive. And in case of an ionic compound, directly charge is there on a particular ion, like KCl, K plus NCl minus. Okay. So rules, if you look into, all elements should be taken, the oxidation state of all the elements should be taken 0. Okay, elemental state would have 0 oxidation state. And in case of monoatomic ion, be it negative or positive, the charge on the ion is equal to oxidation number. And generally hydrogen will have +1 oxidation state. Where exactly it would have negative oxidation state?
In the electronegative elements.
No, with the electropositive.
Metal hydrogen.
Whenever it combines with more electropositive elements like alkali metals, hydrogen will be negative. So that is metal hydrides basically. Generally oxygen will be what oxidation state generally in all its compounds?
-2, sir.
-2.
Where exactly it will have -1?
Sir, in peroxide.
Peroxide. There is something called superoxides also. What is the oxidation state there?
-half.
-half. When oxygen combines with fluorine, oxygen will be negative or positive?
Positive,
Positive,
sir.
sir.
Because
Because
fluorine
it
is
is
more
more
electronegative or
electronegative.
less electronegative?
More electronegative.
So fluorine will be minus and oxygen will be plus.
Plus.
And fluorine in the entire periodic table, the element which would always exist in single oxidation state without any changes, fluorine, that is always -1. Whereas the other halogens of the same group depends on the elements with which they combine. If remaining halogens, chlorine, bromine, iodine, combine with oxygen, oxygen is more electronegative, it will take away electron and halogens will be positive.
Positive.
So in positive oxidation state, halogens exhibit +1, +3, +5, +7. In negative oxidation state, -1. When it comes to metals, first group elements always +1, sodium, potassium, rubidium and all. Second group elements, alkaline earth metals, will always be +2, beryllium, magnesium, sodium, calcium and all. So these things.
Sir, you're muted.
You are muted, sir.
I think it was disturbing for host, that's why Madam muted me. Madam has muted me. Sudha madam.
Sorry, sir. Sorry.
It's okay. Probably you didn't like chemistry.
No, not at all, sir.
Okay.
ಅದು ಏನೋ ಇದು ಮಾಡಕ್ ಹೋದೆ ಅದು ನಿಮ್ಗೆ ಮ್ಯೂಟ್ ಆಗೋಯ್ತು ಸಾರಿ
Okay, ಇರ್ಲಿ. No problem. So in a neutral compound, if you are going to calculate oxidation state, sum of the oxidation state should be equal to 0, because any neutral compound will be having equal positive and negative charges, electrically neutral. In case of a polyatomic ion, be it positive or negative, total charges on all the atoms must be equal to the charge on the ion. What does it mean when I say that? Okay, we'll see with some examples. Okay. Now what I'll do, I'll give variety of compounds for examples. You should calculate oxidation numbers. Okay, we'll take calculation. Calculation of oxidation. Okay. Now 1 or 2 samples I'll work out. Next, you should start working out. Okay, we'll take it first. Okay, we have this simple one. I'll take C2H6. Okay. Tell me, what is this compound? What is this compound?
Sir, ethane.
Ethane. In ethane, if at all, if you are going to calculate oxidation state, is it for carbon you calculate or hydrogen?
Hydrogen.
Hydrogen you calculate. Under rules we have found out, no? We know oxidation state of hydrogen, we know. How much is oxidation state of hydrogen in most of its compounds?
Minus
1
1.
plus 1.
Plus 1.
Plus 1. With metals
Plus one,
only it is
plus one.
minus 1. So, for which one we need to calculate now?
Carbon.
Generally the element for which the oxidation state has to be calculated will be underlined. This underlined element we need to calculate. Is it a molecule or ion? Ethane.
Molecule.
Molecule.
There's no charge. If there were to be -2 like this or +2 something like that, it would have been an ion. This is a molecule. In case of molecule, sum of the charges on all the elements must be equal to 0 or charge.
0.
We need to calculate oxidation state of carbon. How many are there?
2.
So always unknown is X. And how many hydrogen is there? 6. What is the charge on hydrogen?
Plus 1.
Should be equal to
0.
so 2x is equal to
Minus 3. X is minus.
so carbon here is present in -3 oxidations. That's the meaning. Okay, I'll take a particular ion so that you will understand. Okay, I'll take NH4 plus. Okay, NH4 plus. It's a ion. Now tell me, in this NH4 plus ion, which element oxidation state we need to find out?
Nitrogen.
Nitrogen.
Because hydrogen we know. So in the question they would have underlined nitrogen. Underlined element oxidation state. So X plus 4 into charge on hydrogen will be plus 1 is equal to, is it a ion? NH4 plus is a ion or molecule? So sum of the charges must be equal to 0 or plus 1?
1.
So X is equal to 1 minus 4. So X is equal to minus 3. So in this particular case, nitrogen is there in the -3 state. That's the meaning.
Sir, if it is an ion, then we need to take the total charge in the ion, no, sir?
Yeah, sum of the charges must be equal to total charge on the ion. So
Okay.
plus 1. Let me take one anion also so that things will be much more clear. 3. Okay. SO4 2 minus. Here you tell me, oxidation state of oxygen we are calculating or sulfur?
Sulfur.
Because oxygen we know. Generally oxygen, whenever it is there with electronegative element, it will be, what is the oxidation state of sulfur? Oxygen.
Minus.
Oxygen -2. So X, how many oxygen are there? 4. What is the charge on each oxygen? -2. Sum of the charges must be equal to charge on the ion. How much is the charge on the ion?
Minus 2.
-2. So X minus 8 is equal to -2.
Sir, X is equal to 8, sir.
Pardon me?
Yes, 6. Sorry.
X is equal to +6. So sulfur is +6.
Excuse me, sir.
Sir,
For the first sum, we took C as the charge on C as -3. Then for nitrogen, how is it 3 minus?
for which one is 3 minus?
Sir, nitrogen we took 3 minus, no, sir. But for carbon, we took -3. Why is that?
Why is that mean? What is that? Carbon in ethane has -3 charge. Nitrogen in ammonium ion has 3 negative charge. It need not be same, need not be different. Anything it can.
Sir is asking -3 and 3 minus, are they same?
Okay. Oh, that one. Okay. The way we have written. Okay.
Yes, sir.
It is more or less same. Only convention. By convention, we have written all the way -3, -2 like that. Of late, since it is kind of confusion, is there. That's why first digit we write and then minus. Otherwise it is no different. Okay. So 3 minus minus 3 both are same. Better you write the digit first and then the the charge minus or plus rather than like this. Okay. This is my practice actually, which makes me write like that. Otherwise literally no wrong. 3 minus 3 minus. Okay. Likewise here plus 6 you can even write it as 6 plus. Just by convention, that's all. Just to minimize the confusion. That's all. Is that okay? Otherwise no problem.
Yes, sir. That's okay, sir.
Yeah. Now you write down this. I would give some more examples. You need to work out. Is this complete now, all of you?
Yes, sir.
Yes, sir.
Okay. So I shall give some more molecules to keep working out. Come on. Fourth one. Take down. Okay.
Therefore, carbon first one is -1.
Okay. You calculate. No problem. We'll come back and verify everything. Okay. Underlined atom is what you need to calculate. Write down first. Don't calculate. Write down because I'm going to give some more compounds. I'll scroll down. You'll not be able to see.
Sir, can you show?
Sir, last class we have done the fifth one.
Fifth one, KCl was okay. No problem. Correct. While taking the example we would have done. Okay, I'll scroll down. I'll give some more. Write the just compounds. Then you can calculate. Okay.
Sir, what's the name of eighth compound?
Oxalic acid.
Which elements oxidation state should we find in the 8?
Here. I think you can also find by yourself because hydrogen we know, oxygen we know. It is standardized. Only carbon we need to find. Correct? Write only compounds and ions. I'll move down.
Sir, just a minute, sir.
Just write the compounds. You can calculate. I'll give you time. Okay. Do one thing. You finish off these things. We shall take a little more. Finish off these 12 totally, of which 3 I have worked out.
Sir, could you show the sixth question, sir?
Sir, can you name the eighth compound, sir?
Pardon me?
Sir, can you name the eighth compound?
Oxalic acid.
Yes, sir.
Sir, are you speaking?
Pardon me?
Sir, are you speaking?
I didn't get you. You have completed or what is that you do?
No, sir, I was just asking whether you're speaking because I thought it's my internet.
No, no, I'm just waiting for you to complete.
Okay, sir.
Okay. So you thought that I'm speaking and you can't hear me.
Yes, sir.
Okay. Okay. I'll give you 2 more minutes. You can work out.
Sir,
Yeah, tell me.
sir, any non-metal which it is in combination with oxygen will take a positive oxidation number, sir.
Metal will always be positive.
Living metal, sir, if there is a non-metal and non-metal combination with oxygen.
Oxygen will always be negative except with fluorine.
Yes, sir. So the other non-metal will always be positive. It is with
Correct.
oxygen.
Correct.
Sir, can oxidation number be 0?
You found zero oxidation number.
Yes, sir. Actually, I think it's my
Yes, sir.
mistake, but can it be 0?
Why not?
Finish, sir.
Completed, huh?
Yes, sir.
Okay. Let us see how many of you have done correctly. Okay. What is the oxidation state of carbon in this benzene?
Sir,
Pardon
Sir,
me?
1 minus.
1 minus, huh?
Yes, sir.
yes,
Yes,
sir.
sir.
Yes,
Yes.
sir.
Okay. Let me.
Yes, sir.
I need to keep 6 carbon as what? 6 x plus 6 into plus 1 should
Plus
be equal to
1.
what?
0.
0.
So 6x is equal to minus 6.
X
X
is
is equal to
minus
minus 1. You can see here in ethane, carbon is minus 3. In benzene, carbon is minus 1. Okay. See, that is the one of the important factor which makes carbon form many compounds. It can vary its oxidation state from plus 4 to minus 4, including 0. That's the specialty of carbon, right? This is potassium chlorate, KClO3. I think somebody told me that I have calculated the last class. Okay. Anyhow,
5 plus.
I would tell
5
you potassium is plus 1 or plus 2.
plus
Plus
1.
Plus
Because
1.
it's second group or first group.
First
First
group.
group.
That is alkali metal or alkaline earth metal.
Alkali metal.
So it is plus 1. Chlorine X plus 3 into oxygen
Minus 2.
Minus 2.
Minus 2.
is equal to
Equals 0.
0.
0.
So X,
6
this is
minus
minus
5.
6 becomes minus 5. So X is equal to plus 5. Correct, no? So X
Yes,
is
sir.
plus 5. Oh, we'll calculate for sulfur now.
2 into 1.
Sodium
2
should be
into
plus 1 or
1.
plus 2.
Plus 1.
Plus 1.
2 into plus 1.
Plus
Sulfur
X.
X plus 3
Minus
into
6.
Minus 2.
Minus 2.
is equal to 0.
0.
So 2 plus X minus 6. So X minus 4. So X is equal to plus 4. As simple as that. Correct? We'll take it next. H2SO for sulfur.
Plus 6.
6.
Plus 6, huh?
Yes, sir.
Yes.
Directly I'll write hydrogen plus 2. Okay. Plus sulfur is X. Plus 4 into minus 2. It's a molecule 0. X minus 6 is equal to 0. X is
6
equal to 2.
plus.
Now, look at this. We have worked out this now. Sulfate. Sulfur is plus 6. And this is sulfuric acid. If you remove these two hydrogen, it becomes sulfate. Obviously, the sulfur in sulfate is same as sulfur oxidation state in sulfuric acid. Both are plus 6. Correct, no? Here,
Yes, sir.
equal to charge on the ion minus 2. Here equal to 0 because hydrogen is there balancing minus 2 charge. So both should be same. Then come to this oxalic acid. So some of you are asking for the name oxalic acid.
3 plus.
2 into plus 1 plus 2
Into X.
plus 2x plus 4 into minus
Minus 2.
is equal to 0.
0.
2x minus 8. This again plus 2 is that is equal to 0. So 2x therefore is equal to plus 6 and x is equal to plus 3. No. What is this compound K2CrO for anybody?
Potassium permanganate.
Potassium.
Permanganate.
Sir, that KMNO4, sir, that is.
Then what is this?
Potassium dichromate.
Dichromate. Dichromate means there should be 2 chromium, right?
CR2O7,
Yes, sir.
sir, that is.
Cr2O7.
Then what is the name of this?
Potassium chromate.
Chromate, sir.
Chromate. Very good. Okay. Potassium. What is the charge on potassium?
1
Sir,
1
plus
into
1.
plus 2.
Plus 1.
Chromium X
X
plus 4 into minus 2
Minus 8, sir.
is equal to 0. This is minus 8. This plus 2 becomes minus 6. So X is equal to plus 6.
plus
Can you tell me what is the oxygen instead of carbon here?
0
Sir,
sir.
0, sir.
What is this compound?
Sir, glucose.
Glucose.
Exactly. This is glucose. Look at this. Here 6x plus 12 into
12
1 plus
1
12. 6 into minus 2 minus 12
minus 12.
is equal to 0. So 6x is equal to 0. X is equal to 0. That means the zero oxidation state for carbon. Okay. How about what is the name of this radical?
Carbonate, sir.
Carbonate radical. Correct. So X for carbon plus 3 into minus 2 is equal to charge on the radical minus 2.
Minus 2
X minus 6 is equal to minus 2. X is equal to plus 4.
plus 4.
What is this ion? What is the name of this ion?
Dichromate ion.
Exactly. If I keep two
Dichromate.
potassium here, correct, potassium dichromate. You remove those two potassium, it's simply dichromate ion. That's all. Dichromate ion. So 2x, this will be plus 7 into minus 2 is equal to minus. So 2x minus 14. 2x is equal to plus 12. So x is equal to plus 6. So look at this. In potassium chromate, x is plus 6. In dichromate, if you add potassium there, this becomes potassium dichromate. In both the compounds, x is plus 6 only, oxidation state.
Sir, so in all cases, oxidation number of chromium is plus 6 only, sir.
No. It need not be in every case plus 3. For example, CrCl3, chromium chloride, it is plus 3.
Yes, sir.
It would be existing in plus 3 and plus 6 oxidation state. Let me take some more compounds now. Simultaneously, you have to write the compounds, then start working because I need to scroll down. Okay. So, I need that out to underline because oxygen, we know the remaining element we need to find out. That's all. Complete. I'll scroll down. Don't calculate after
1
marking
minute,
down
sir.
everything.
Sir, 1 minute, sir.
Okay.
So what is that 19th one called?
Lithium aluminum hydride.
Okay, sir.
Sir, in the 20th one, is it sulfur, sir? We need to find.
Exactly. And wherever I have not given underline, both you have to write oxidation state. For 18, both you have to write.
So for copper also we have to write both.
For copper,
Yes, sir.
no. No, whatever I have written for that. Uh, just the
Okay.
representation, whatever I have given
Yes,
for
sir.
that.
Yes, sir.
Okay.
Sir, can you show the 16th sum again?
Don't keep calculating. Just write down all the compounds that I write. Then you can start working out. Okay.
Okay, sir. Done, sir. Thank you, sir.
Well, come on, just write down the compounds. Here I am going to underline for Na2S2O3, sulfur. Okay, work out these many now.
Completed, sir.
Completed. All of you. So shall I take up now working? All of you have worked out?
Sir, just a minute, sir.
Okay. Is this complete now?
Yes, sir. Yes, sir.
Yes, sir.
We'll take up one word. Yeah. What is the oxidation state of iron in Fe2O3?
3, sir.
Plus. 3
Plus.
plus.
Okay.
3 plus
2x plus 3 into minus 2 is equal to neutral molecule, so 0. So 2x minus 6 is equal to 0. Fine. Oxidation state of iron in this?
2
2.
plus.
2 plus
Lower oxidation state should end as in the name OUS. Higher oxidation state should end as IC. So this is ferric oxide. This is ferrous oxide.
ferrous oxide.
Higher oxidation state compound must end as IC. Ferrous. OUS. Okay, no problem. What is this oxidation state of Mn2O7?
7 plus
7 plus.
This will be plus 7 into minus 2 is equal to 0. So 2x shall I write directly is plus 14. Therefore, x is equal to plus 7.
What is the name?
A manganese oxide only you can say.
So because 2 and 7 is there.
Dimanganese oxide, no problem. But you have to remember that it's plus 7 oxidation state.
Sir,
Ah,
for iron, only 2 possible oxidation numbers are there, no, sir? Plus 3
there
and
are other compounds where iron will go beyond this, but these are the most stable oxidation states of iron. Though iron is known to exhibit some other oxidation states also, but these are common and most stable oxidation state of iron. For example, when you take FeS2,
okay.
since you are
Yes, sir.
asking me, in case of iron sulfide, so here iron is x minus 2 into 2 is minus 4. Sulfur is minus 2 there. So 0. So x is equal to plus 4. So there are cases. Okay. Coming back to this. In potassium permanganate, this is potassium permanganate.
plus 7
Plus
7
1,
plus.
plus x minus 2 into 8. Okay, let me write one more step. Is equal to 0. So x, this is minus 8 becomes minus 7 is equal to 0. So x is equal to plus 7. This is potassium permanganate. Then what is this ion called?
Permanganate.
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 Permanganate ion is what you are telling. That means this ion must be obtained by removing K, right? If I remove K, how many charges is like I'm going to remove? +1. So remaining portion should be -1 or +1?
+1, sir.
Correct,
So
no?
7
So if
minus.
it's +1, this should be -1. But I've written -2 here, or 2 minus. So
Sir,
Sir, in this it
+1.
comes 6, sir, not 7. In this Mn is 6.
That is also correct. So it is not permanganate ion, instead manganate ion. Simply we say manganate ion. So if I add potassium here, you have to add 2 potassium. Then it becomes potassium manganate. This is potassium permanganate. Okay, we should calculate oxidation state. X manganese.
Sir, could you repeat this?
Here, MnO4 is -1. MnO4 minus ion is called permanganate ion. If you add potassium there, it becomes potassium permanganate. Likewise, if it is MnO4 -2, MnO4 2 minus, it is called manganate ion. If I add potassium here, what will be the formula? K2MnO4.
Potassium manganate.
Then it becomes potassium manganate. That's all.
Okay, sir.
I'll write in short potassium manganate. Potassium manganate contains manganate ion. Potassium permanganate contains permanganate ion. The major difference is oxidation state of manganese. Okay. In potassium permanganate it is +7, whereas in manganate ion, what will be the oxidation state? 4 into -2 is equal to -2. So x minus 6 is equal to -2. X is
6.
equal to, therefore, this is, sorry, 8 it is. X is equal to +6.
Sir, so we are subtracting 1 if we add like potassium again.
That's what, when for example, when NaCl is added to water, how does it dissociate in water? Na plus and Cl minus. Likewise,
minus.
if you add KMnO4 to water, it dissociates as K plus and MnO4 minus. So K plus is out. So what remains is MnO4 minus. Likewise, if you add K2MnO4 to water, what you get? 2 potassium ion, 2 K plus ion, and 1 MnO4 2 minus ion.
Yes, sir.
Okay. Now, see, this I have not underlined. You need to write both. What is the oxidation state of sodium?
1 plus.
+1.
Hydrogen.
1 minus.
-1.
What are these compounds called?
Metal hydrates.
Metal
Metal
hydride.
hydrides.
In this particular case, it is called sodium hydride.
Sodium hydrate.
Correct. Coming to this. This is lithium aluminum hydride, as the name itself suggests.
Sir,
2 plus.
oxidation number of aluminium is always +3, no, sir?
That also you can fix it. Here, everything is fixed.
Yes, sir. Yes, sir.
For that matter, in this particular case, everything is fixed. You better, I can remove this underlining also. You just need to write oxidation state of everything.
So 1 second, can you scroll up?
Pardon me?
So 1 second, can you scroll up?
Okay.
Yes, sir.
That's all. Lithium aluminum hydride. Aluminum is +3. Of course, we didn't standardize aluminum and in our rules, but in most of its compound, it is +3. If you add all the charges, it should be 0. +1, +3, -4. Overall positive charge is +4, overall negative charge is -4. It is 0. This 20th, I'll come back after 24. Give me oxidation state of sulfur in S8.
0.
Because
It is an
Elemental
element.
form.
Element.
0, it is elemental. Yes. Oxidation state?
0.
0, sir.
Elemental.
0.
0.
0. Oxidation state?
2 plus.
2 plus.
Charge on the ion in case of monoatomic. Those are all pretty simple. What is the oxidation state of sulfur here?
2 plus.
2 plus.
2 plus.
Plus.
+2, huh?
Yes, sir.
Yes, sir.
That means you have calculated like this. This is 2 Na plus, so 2 into +1 plus sulfur is 2x plus 3 into -2 must be equal to 0. So 2 plus 2x minus 6 is equal to 0. 2x is equal to 4. X is equal to 2. This is the way? Correct
Yes,
now?
sir. Yes, sir.
Yes, sir.
Now, what I can tell you is the oxidation state that is calculated by you, which is +2, is wrong. Now, immediately, calculation is fantastic. Everything is correct. Why? And how? Correct,
Sir,
no?
Na is peroxide means
Sir,
the oxidation number will change, no sir? Because Na
This
peroxide,
is called sodium thiosulfate. The compound is sodium thiosulfate.
sir, is S2O3 a radical?
See,
Or
anything that is existing as an ion, cation, anion, or a free radical, it is radical. Radical can be even charged species also. When it is added to water, sodium comes out as Na plus. Obviously, this should be thiosulfate radical. So
Sir,
S2O4.
then S2O3 would have a different oxidation number. We didn't take that.
What oxidation state? You only tell me. S2O3 is 2 minus only. See, 2 sodium is 2 plus. So when it is 2 plus, to balance that one, this entire
Yes, sir. 2
part should be
minus.
negative.
Sir, if we take 2 minus and calculate,
Yeah, it will come
this
same.
one will get 4.
No, you can calculate.
Okay. Yeah, same.
But this is not correct. That's what I can say. And your curiosity will have to remain as such. Let me give some more compounds now.
So
Now,
maybe like one of the elements will have another oxidation state, like 2 oxidation states.
then why do you think so? Why do you think one of the element has another oxidation state, Lada? Who told this?
sir, is X is equal to 1?
Uh-huh. No, one of the element has another oxidation. Is it Pranati told?
Yes, sir.
Okay.
No.
Who told this? One of the
Yes.
element has
Samprati.
Samprati. Okay. Now, let us keep this exclamation as such. I'll give some more compounds. Probably this exclamation would enhance more. Okay. So probably there are more surprises awaiting for us. We'll take some more examples. Okay. We'll come back to this point. Okay. We'll come back to this point. Sure. Why it is not +2, I'll tell you. But before that, you have to work out this. 25. Can you work out for these four?
Sir, can oxidation number be a fraction or a decimal?
So if you are getting fraction, you write it.
Yes, sir.
Let's see.
The last one, it is CN whole 6, sir.
Last one.
CN bracket 6, sir.
Yeah, correct.
Okay.
Sir,
Yeah, tell me.
so for that sodium thiosulfate molecules,
Ah,
there are two sulfur atoms, no, sir. Is it possible that one has one oxygen state, other has another?
okay.
I
You are
don't know,
asking
sir.
about Na2S2O3, sodium thiosulfate.
Yes, sir.
We'll
Is
come
it
back to that.
possible like one?
You work out these things. We'll come back to that.
Sir,
Sir,
what
I'm
is
not
the
getting the last
oxidation
one,
state
sir.
of CN?
We are not getting last one.
Okay. Okay. We'll do something. Let's see. If you're not getting last one,
So what should we take carbon as?
I don't know. It is your problem now. You may say that it's fixed or something like that. Okay, let me change that.
Sir, it is what, sir? C2? C2, sir, that is.
C5H5 minus.
C5, okay.
Let me write it again. That is 5, no? C5. I should write like this. Okay. Let's take up this now, one by one. Okay. What is the oxidation state of chromium in CrO5?
10 plus.
10, sir.
10 plus. Okay. That means X plus 5 into minus 2 is equal to 0. X minus 10 is equal to 0. So X is equal to plus 10. That's what you say, right?
Yes.
Okay. What is the oxidation state of sulfur in this? So
10
5
by
by 2 plus.
4x plus 6 into minus 2 is equal to 0. This will be minus 12. This will be, sorry, plus 10, minus 10 is equal to 0. So what will be X?
5 by 2.
5 by 2, sir.
So 10 and X is equal to 2.
Sir, but how can charge become a fraction?
Sir, in superoxide it was fraction, sir.
Minus half. In
Okay,
some
okay.
cases it can be fraction. But I don't know about this case. Whatever you have calculated, I have written here. Let's see. In case of this Fe.
8 by 3, sir.
8 by 3. 8 by 3 plus.
Why 8 by 3?
Sir, 4
What is the charge on sulfate?
minus 2.
Huh.
Correct, no? You have to take entire sulfate as a whole. This is minus 2.
Sir,
Sulfate is minus 2. We
27.
have calculated, no?
Sir, it will be plus 3 then.
So 2x,
Plus 3.
you have to take entire sulfate into account. Plus 3 into minus 2 is equal to 0. So 2x is equal to plus 6. X is equal to plus 3. Okay. In Fe3O4.
8 by 3.
So
So
3x
this is 8 by 3.
minus 8 is equal to 0. So 3x is equal to 8. X is equal to 8. Okay. How about this now?
Plus 2.
6 by.
Plus 2, sir, X is.
Why? How is it plus 2?
Sir, cyanide is minus 1.
Fantastic.
Potassium is plus 1.
Super. That's the way. Very good. For example, let's say you don't know what is CN. You take a compound of CN, no? HCN. H is plus 1, CN is minus 1. You must know that. So potassium 4 into plus 1 plus iron X plus 6 into minus 1. 0. So X minus 2 is equal to 0. X is equal to plus 2. Correct? How about this C5H5 minus? You need to find out carbon.
Minus 6 by 5. 6 by 5.
5x,
Sir.
correct? Plus 5 hydrogen is equal to minus 1. 5x is equal to minus 6.
minus 6.
So x is equal to
Minus 6 by
6 by 5. So again fractional. Now we'll get back to which are all correct or which are wrong. Okay. So this is wrong. This is wrong. You may think it is x. Okay, that's why I'm circling it. Okay, this is correct. This is wrong. This correct. Somebody taken Cn as -1. That's fantastic. This is correct. Now again our surprise element has enhanced, right? So here it became wrong. This became wrong. So what is this? All those things. Why things are becoming like this? Correct? No. Now in some cases, especially polyatomic ions. In case of polyatomic ions, you need to consider the structure. If you don't consider the structure, it becomes wrong. Okay, it becomes wrong. So now you can take up this sodium thiosulfate, for example. First, we'll take up sodium thiosulfate. Let me write down, okay, separately. What is that important thing to note? In case of polyatomic ions, ions or molecules, structure must also be considered. Also be considered to calculate oxidation number. Okay, you should know structure, otherwise it becomes wrong. Okay, how is that exactly? So that is the case of number this 20th. Let me write the same number. This is sodium thiosulfate. This here the structure is actually like this. Sulfur is attached to 3 oxygen. And where there is one more sulfur, no, that is bound to this sulfur. And one of the oxygen is doubly bound. Remaining 2 single bonded have 1 negative charge each. And this each oxygen negative charge will have 1 Na plus attached by ionic bond. Like this. Now you need to calculate oxidation state. This is sulfur, bond sulfur. It doesn't have any charge there. It will have 0 oxidation state. Let me write in a separate color. Zero oxidations, because it is attached to same element, then it will become 0 oxidation. Now this oxygen which is completely bound to this sulfur will have 2 minus. This oxygen which has 1 single bond will have -1 charge, because of which sulfur will have to balance that -1 charge with +1 charge. So you have to count singly bonded oxygen as -1, doubly bonded oxygen as -2. Is that okay? So this is -1, this is minus.
Sir, is it 4 minus?
4 plus.
It's a 4 plus, sorry.
Exactly. So 1 sulfur is 0. Oxidation, OS means oxidation state, or ON, no problem. So another, which is called central oxygen. In the structure, the central oxygen. So this sulfur is +4. Okay, because totally due to 3 oxygen, how many negative charges are there? Total negative charges -2, -3, minus 4. So it should be plus 4. So you have to look at this structure, otherwise things become wrong. Okay, yeah. We'll take up remaining and finish up. CrO5, it is quite popular. I think remaining all we have done. Oh. CrO5 is quite popular compound. They would ask you in the exam also. CrO5. This structure is very interesting structure. Here, one double bond O will be there. Remaining 4 oxygen would be bound with single bond to chromium. Okay, and they would have in between one bond to each. Okay, this is called butterfly structure. Butterfly structure. So I told you when oxygen is completely bound to central metal, then it becomes 2 minus. Then singly bonded oxygen must be counted minus 1. So can you tell me now what is the overall negative charges due to oxygen? What is the overall negative charge?
Minus
Minus 10, sir.
6, sir.
Hey, where
Minus
is
6.
minus 10, man? This single oxygen which is completely bound to chromium is minus 2. Singly bounded oxygen is minus 1. So how many negative charges overall?
Minus 6, sir.
Shashank.
Minus 6, sir.
So what should be the chromium?
Plus 6 plus.
Like that. Is that okay? So
Yes, sir.
double bond oxygen is minus 2 oxidation state. Single bond oxygen is minus 1 oxidation state. Total negative is equal to minus 6. Therefore, chromium oxidation state is equal to plus 6. That's all. So this is called butterfly structure. Then we have Fe3O4. This I want you to analyze somehow. I don't know how would you get the information. You take this one as homework. I think only 2 are there. Rest everything is fine. Okay, you have to put in efforts and find out what is exactly wrong here, why it is so. From some literature or somewhere you have to get it. Is that okay?
Sir, Fe3O4 is Fe2O3 plus Fe1, sir.
Exactly. One answer already I found. Okay, let me take this.
So there'll be 2 oxidation states.
Yes.
For the first one, it's 3 plus, and second one, it's 2 plus.
Exactly. So it is actually FeO dot Fe2O3. FeO dot Fe2O3. Now, the oxidation state of oxygen is always 2 minus. So this first iron is plus 2. And overall negative charge due to 3 oxygen is minus 6. And 2 iron has to bear plus 6. So plus 6 divided by 2. Each iron will be plus 3. Is that okay? So this is called mixed oxides. This Fe3O4 is called mixed oxide. It's also called ferrosoferric oxide. Ferrosoferric oxide. Okay, there is ferrous ion, ferric ion both. Okay, so one iron is plus 2, another iron is plus 3. Okay, one more is
So
remaining.
there's
Let
no
me complete.
structure.
Pardon me?
No structure difference in this case, Fe3O4. We are not considering the structure.
No, it is not the structure because it's a mixed oxide. It's the mixed oxide. Fe2O3, you know, this is plus 6, plus 3. And FeO is plus 2. So it is a mixed oxide. It has 2 different oxides in it. And the last one is, let me complete of this. Last one, finish off. This is called sodium tetrathionate. 4 sulfur. Thio means sulfur. You can see what is the name of this? Sodium thiosulfate, sulfur. Sodium tetrathionate, we say. Okay. So which is the number, that one? 26th. 26. Na2S4O6. The structure is like this. Okay, 4 sulfur continuously attached to one another. Double bond O, double bond. Double bond O, double bond. 4 oxygen. And each sulfur is attached to 2 oxygen by double bonds, 1 oxygen by single bond. And this singly bonded oxygen having negative charge will be attached to Na plus. Now, what is the oxidation state of these two sulfur? Whenever sulfur is attached to another sulfur, it will have 0.
0.
What is the total negative charge due to these 3 oxygen? Can you tell me? This is -2, whole and soul attached. This is singly bond, -1.
5.
5.
So, -5, this should be +5. Like that, -1 here, -2, -2. So total negative charge -5. So this will be +5. Is that okay? So therefore, 2 sulfur atoms, 0 oxidation state, and remaining 2 sulfur have +5 oxidation state. So these 2 sulfur bound to oxygen.
Sir, why is sodium plus and minus?
That is ionic interaction, we say. These are all covalent bonds. This is minus, sorry. That is, oh, you are asking this one, huh? This should be plus.
Yes, sir. Yes, sir.
That is the question you asked me?
Yes, sir.
No, that is just by mistake. Na plus, Na plus. Hope it is completed, done.
So we should take only bonded ions or molecules, sir.
This is Na plus and O minus. It is ionic interaction. And Na is plus, so O is minus. You are considering the oxidation state of that also.
Yes, sir. So since these 2 sulfurs are not reacting, they are taken as 0.
Not that. They have reacted, that's why they are bound. Whenever sulfur is bound to sulfur, oxidation state becomes 0 because both will share equally the electrons. Oxidation state will be assigned only when electronegativity difference will be there between 2 atoms. If atoms are same, then the oxidation number will be 0. For example, chlorine. 2 Cl atoms have been bound. What is the oxidation number? 0. N2 0, O2 0. Like that, sulfur when bound, oxidation state is 0 because they share equally electrons, and electron will not be shifted onto any one particular atom. When sulfur is attached to oxygen, oxygen will be negative and sulfur will become positive. If oxygen is completely bound with double bond, then oxygen will be -2. If oxygen is bound with single bond, then oxygen will be -1. Is it
Yes,
okay,
sir.
Mr. Shashank?
Yes, sir.
Any doubts here, students?
Sir, if we
Sir,
think of this,
we'll
Tell me.
sir, if we think of the structure of carbon, sir, we have to keep all the 4 bonds filled, no, sir. But in sulfur, why are we not doing that?
I didn't get. Come again, please, Abhinav.
Sir, in if we say carbon, sir, then all the 4 like we write 4 lines, no, sir, like to represent that each of the 4
No.
valent
That's
bonds
fine.
are.
That's fine. Carbon in all its compound exhibits tetravalency, and exceptions are found, like in case of carbon monoxide and all, where it will not be tetravalent. Sulfur can be divalent, tetravalent, hexavalent also.
Sir, I'm asking if sulfur can be like divalent and tetravalent in only like one molecule compound.
It is variable. That's why here some sulfur is divalent here, and the other sulfur is hexavalent.
So even in this one compound only, it can be.
Yeah. Why not? It can be. That's why polyatomic molecules will have different structure. It can happen.
Yes, sir.
Yeah.
Sir, we'll not know the structure of any compound they give, no, sir. Then how to?
That's why some common compounds like this butterfly structure is quite popular. You should know. It is not that every compound will be asked. Some common compounds, whichever I have given here, generally
Yes, sir.
I have given little excess only.
Yes.
They'll ask you either CrO5 or Fe3O4, such kind of compounds, not one. Or sodium thiosulfate, not beyond that.
Yes, sir.
Okay. So fine, we shall stop at this stage. Meet you for the next class. Bye bye.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Sir, how will we know when we should write the structure, sir?
Thank you, sir.
That is the thing. You will know only when you know the structure. That's why these examples have been worked out. Correct, no? So some common molecules will not have any deviation in calculation of oxidation numbers, but some complex molecules like Na2S2O4, O3, or something like that. See, one for example here, CrO5, you can get to know plus 10 cannot be oxidation state for the reason that chromium, if you write the electronic configuration, it will have only 6 electrons in the valence shell. Chromium, it can lose only 6 electrons, so oxidation state can be maximum plus 6. So if you are calculating plus 10 for a compound chromium, then it would be wrong. So you should think, oh, probably there is some difference in the structure.
Sir, the maximum oxidation number can only be plus 6, no, sir. So
No.
if it is
Plus
8.
7 for manganese,
+7.
and in the entire periodic table, plus
Yes,
8 is
+8.
also seen with ruthenium and osmium.
okay, sir. So
That
if
is the
it's
maximum.
more than plus 8, we'll get to know that we should write the structure.
Like that also you can think. Correct. That too, plus 7 plus 8 will be only 3 elements. Plus 7 manganese, plus 8 is osmium and ruthenium. No other elements go up to that oxidation state. Whereas plus 7 is possible with halogens.
Yes, sir. Thank you.
Okay. So fine. We shall meet for that. Thank
So
you.
plus 8 is for
Pardon me?
plus 8 oxidation state.
OS, osmium, Ru, ruthenium. I'm writing here.
Ruthenium.
Osmium, OS,
Yes, sir.
Ru, ruthenium. Both of them have oxidation state plus 8. They are the iron group, below iron. 8 electrons they have in the valence shell, they would lose all the 8.
Yes, sir. Plus 7 is for manganese and halogens. Is possible.
Correct. Halogens, that too when they combine with oxygen.
Yes, sir.
Correct. Okay, Nitishri.
Yes, sir. Yes.
Thank you. Bye-bye.
Thank you, sir. Thank you, sir.
Yeah, thank you.
Thank you, sir.
Bye-bye.
Thank you, sir.
Yes, I'm going to end the meeting.